Guys, let's transform a function. Let's, I want to look at the function y equals x. So let's do a quick investigation together. Ready? Graph. Give me a point on the graph.
1, 1.
1, 1. Give me another point on the graph.
2, 2. No.
Other direction.
0, 0.
We okay with that? Why not? No reason. So, domain infinite, range infinite, blah, blah, blah. Intercepts. Description, a line, increasing. So here's my question for you. I want to move this line up by 2. What am I going to do?
Add 2 to the x.
Agreed? What if I want to move it down by 2?
Minus 2.
What if I want to move it up or down by some value k?
X plus k.
Agreed? Okay, let's go back to y equals x. I want to move it to the right by 2.
So it would be negative 2x. Y equals negative 2x. That's on.
It's all right. So I want to move it to the right by 2. How am I going to do that?
X minus 2 in parentheses. That'd be the same as x minus 2.
No.
But there's nothing else.
So I take this point and I move it to the right by 2. And I take that point and I move it to the right by 2. And I take this point and I move it to the right by 2. Yeah. What if I want to move it to the left by 2? X plus 2? In parentheses? So I move to the left 2. I move to the left 2, and I move to the left 2. And there's the graph of y equals x plus 2. So what if I want to move to the left or right by the value h?
The x minus h in parentheses.
cool with that? All right. I want my graph to go up faster. I want it to go up twice as fast.
Y equals 2x.
Yeah. I want it to go up half as fast. Y equals half x. Yeah, I got so many colors, huh? I want it to go up a times as fast.
Y equals AX.
So let's put it all together. A parentheses x minus h plus k. Let's talk about h and k. Start the graph over again, shall we? Too many things on it now. Everybody comfortable with this, by the way? Like, makes perfect sense. Where's the locator point?
Origin.
The origin. Agreed? Locator point right now is at 0, 0. So I want to move this graph 2 to the right and up 2. So the equation of my new graph is y equals x minus 2 plus 2.
Or Y equals AX.
No, it is not y equals x. It is y equals x minus 2 plus 2. Where's the locator point? I want a graph y equals x plus 4 minus 4. Where's the locator point? Can we agree that these are in fact all the same line? And that h comma k is any point on the line? And I can do the same thing with a different line. I could graph y equals x minus 2 plus 3. Where's the locator point?
It would be 2, 3.
And I could graph y equals x plus 2. Where's the locator point?
0.
Now, because this is the one that's
Yeah,
negative.
yeah.
The one that's in the parentheses
Yeah.
is the opposite. Notice that h comma k is a point on the line. I could write the equation of this line an infinite number of times with different values of h and k and get the exact same line. Agreed? Does that make sense to you guys? Is that this whole thing where I said 3 different lines, y equals x minus 2 plus 2, y equals x plus 4 minus 4, I could just do this all day. And after a while, you'd be like, oh my God, we got it. Stop. And I could do the same thing for this. I can just keep doing this all day. H comma k is pick a line, and there are an infinite number of equations where h and k are just points on the line. So h comma k is a point on the line. I know I wrote it over there, but I'm writing it again over here because I want it with this because I'm going to erase all that stuff. Okay? So let's erase all this stuff. Now, if h comma k is a point on the line, would it be fair for me to say that I could just, instead of h comma k, I could just write x1 comma y1? Some point on the line? Is that reasonable? I don't have to write hk because we just picked h and k. We don't have to use them. So I'm just going to say, well, let's use x1, y1. Now, let's talk about that. Tell me about the stretch factor when we're dealing with a line. What does the stretch factor tell me about that line?
The slope of the line.
Oh, it's the slope of the line, agreed? So A is the slope. But you know what? I don't want to use A for the slope. I want to use M. And I can now rewrite the general equation of the line as y equals m times x minus x1 plus y1. Or x1 and y1 are some point on the line, and m is the slope of the line. This is called point slope form of a line. And here's the fun part. If I told you to write the equation of a line with slope 3 through the point 5 comma 7, here's the old busted way. The old busted way is to say y is equal to 3x plus b, 7 is equal to 3 times 5 plus b, b is equal to 7/15, and y is equal to 3x plus 7/15. Agreed? And then if you're an obsessive calculator person, you get out your calculator and you type in 7 divided by 15, and then you round it off and you write down the wrong answer instead of the right answer. Well, guess what the new hotness is? Oh, y equals 3, the slope, x minus 5 plus 7. Done. Did I do that calculation right? I feel like I did. Yeah, 3 times 5 is 7. Oh, I divided by, why did I divide by 15 instead of subtracting 15? Good grief. And not one of you said, Mr. Hermerding, Mr. Hermerding, Mr. Hermerding, excuse me, Mr. Hermerding. Y'all just let me go. Live on the internet. Awkward.
Make sure we have everyone watching.
You never know. You never know. I might have gone viral this morning.
Another copy.
You guys are gonna get home and there's gonna be like paparazzi outside. Hey, do you know that math teacher guy, Mr. Hermerding? I saw his video on the internet. Guys, which is easier, old mustard or new hotness? New hotness totally easier because you don't have to do anything. You just plug in the numbers, boom, done. Now, there's also something that's sort of interesting about this because has it always bugged you guys that it's minus h but plus k? Yeah, me too. But if I subtract y1 from both sides, look, I get y minus y1 equals m times x minus x1. Hey, look, they're both minus. You're subtracting the value that goes with the variable if you write it like this. Both of these acceptable ways to write point slope form. This one generally more useful because we can stick it into our calculator. But if we think about this as y minus k equals a times x minus h, all of a sudden it's a variable minus the thing that goes with the variable. It's a function of the other variable with minus the thing that goes with the other variable. It doesn't really matter. They're both the same. We just don't usually think about this version because we want to be able to plug stuff into our graphing calculator. We want to be able to do stuff with it, and just having everything written as y equals is convenient. Any questions about this? You need to know this. And you need to use it. I'm assuming that you guys, for the most part, are going to go on to pre-calc and calc, or at the very least pre-calc, get a 4th year of math in before you go out to college. As you'll want to be familiar with point slope form, because when you have a problem that requires the equation of a line, to spend 3 seconds writing it down instead of 3 minutes calculating it, and then making a stupid mistake. When you get around to taking the AP calculus test, this gets you a point. This would have gotten you the same point. This gets you 0 points. So I did a whole bunch of work in order to lose the point that I already had, because I obsessively felt the need to write it in y equals mx plus b form. And then divided instead of subtracted. So yeah, you're done. Now, I know AP calculus test isn't life, but this is still easier, even in real life, even when there's no points involved at all, other than, you know, the whole losing your job part because you can't write this equation of a line properly. After a while, your boss says, we're gonna have to let you go. I'm sorry, you do all the complicated stuff awesomely, and every time you write the equation of a line, you mess it up. So, sorry. You guys good with that? Questions? All right. Let's talk about another equation. X equals y squared. The without a calculator, without Desmos. If you come up with as many pairs of numbers as you can that make that equation true. Many as you can. Just think about them in your head, just start jotting them down, pairs of numbers that make that equation true. More. That's not enough. I want more. For the work.
Yeah, that's what I'm doing.
Gotcha. I see what you're doing. So you're saying that 25 squared is -5? Crazy, man. Is 10 enough? Sure. Brooke, give me one.
1, 1.
Ryan, give me one.
-1, 1.
That's weird. -1 is equal to 1
That
squared.
doesn't work.
Pretty sure that doesn't work.
Or 1, -1.
Oh.
Why does that still work?
Well, because -1 squared is +1.
Oh, okay, got it.
2, 4.
42.
So that doesn't work. Because 4 squared is definitely not 2, it's 16.
Yeah.
But I could put 16 for there, but I don't want to. Helen,
9, 3.
Brooke,
16, 4.
I'm bored.
Okay.
Don't go so big, because my graph, it's got, yeah, sure, why not?
Yeah,
16.4, but now my graph's getting out of control. Ryan,
Where are we? Sorry. I'm rewriting.
we're here. Give me a point.
25.
No, too big. Smaller.
4, 2. 4, -2.
For -2. Henry.
9, -3.
9, -3.
16, -4.
-4. Cohen.
Zero, zero.
Yeah, that's the one I was looking for. I don't want to go any bigger. My graph's going to be way too big as it is. In fact, I'm not even going to go out to 16, but you guys are having so much fun. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 1, 2, 3. 0, 0. 1, -1. 2, -2. 3, -3. Cool. This function is called a sleeping parabola. What's the domain? What's the range?
The domain is x is greater than 0.
What?
Or equal to.
X
Oh, yeah,
is greater than,
Definitely can be equal to 0. Range?
All real numbers.
What?
All real numbers.
Oh, I hate it when people say all real numbers. Give me an inequality.
Negative infinity is greater than, or less than, or greater than, less than y. Less. This is why I use all real numbers, because it's one symbol.
I know. I know. Technically, all real numbers is actually sort of bad. If you're going to use all real numbers, technically you should say the set of numbers it contains, and then it gets just longer, and then you might as well just write an inequality. Or, you guys know set notation? Have you seen that on the interwebs? Did I show it to you?
Yeah.
Oh, okay. And then this one would be, I'd be a little bit careful. It's obvious for these ones, but if you need to write down R to, if you just wrote down -2 in parentheses and you didn't have an R in front of it, people would be like, why is he just writing random points on the board? So you have to be really careful that you designate that is the range if you're going to use set notation. Otherwise, like, well, what's going on there? And how is negative infinity, comma, positive infinity a point? Yeah.
what are the brackets mean?
Bracket means includes. Parentheses means doesn't include. All right, cool. So let's put it in our calculators. I want you to solve for y and type it into your calculator, and then show me the awesome sleeping parabola graph that you come up with. If you are in Desmos, you can technically type in x equals y squared and it will work, but I do not want you to do that. I want you to solve for y. And I want you to type in y equals into whatever you were using as a grapher. And I have a very, very good reason for asking you to do it that way. Henry, how do you solve that for y?
I haven't even started yet, I'm sorry.
Oh, okay. Terrell, how do you solve that for y?
You would square root both sides. I mean,
Yes? Does that give us that graph?
No.
What does that give us?
half of the,
Half of a graph. So how do I get the other half?
The negative
Zero.
Put a negative in front of it. Agreed? Guys, here's the reason I specifically asked you to do this, because this is an important idea. Your calculator deals with functions. This is not a function. Each value of x within the domain has more than one value of y. Yes, with the exception of 0. But the values of x greater than 0 have two outputs, and this is not a function. Now, think all the way back to algebra. None of you had me for algebra, but here's how I talk about the difference between a function and a non-function. You walk up to a soda machine and you put in $1, and you push the button that says Mountain Dew. What should happen? You get a Mountain Dew. You push the button that says orange soda. What should happen? You get an orange soda. That is a function. Input Mountain Dew button, output Mountain Dew. Input orange soda button, output orange soda. That is the definition of a function. An input gives you a predictable output. Now, here's the non-function. You push the Mountain Dew button and you randomly get either a Mountain Dew or a Dr. Pepper. You push the orange soda button, you randomly get an orange soda or a Coke. You push the Coke button, you randomly get a Coke or a grape soda or a Fresca. That is not a function because it's not predictable. There's no guarantee of what's going to come out of that soda machine. When you type in x equals 4, you get either y equals 2 or y equals -2. You cannot do math based on a non-function because you have to have a predictable result. If I do this to my design of my airplane, it will lift off at the end of the runway. That's math. That's a function. If I do this to the design of my airplane, it will either randomly lift off or crash into the swamp. That's not useful. That is not a useful tool. We have to know that if we do this, it's going to lift off at the end of the runway. We have to know that if we push this button, we're going to get that back out. This is a non-function. And so in order to put it into our graphing calculator, now Desmos I did say was a little bit different. Desmos is designed to allow you to enter non-functions and give you a non-function graph. But we're going to really focus on dealing with the functions because what we know right now is we know how to deal with functions. We don't know how to deal with those. So here's my function. Y equals plus or minus the square root of x. Okay, combining them a little bit, but we know how to deal with the y equals. And the first question, how do I vertically shift that function?
add 2 outside of the square root.
Add 2?
Or add k.
Okay.
Sorry.
No, that's fine. Adding 2 is definitely a vertical shift, but we can generalize that to plus k. How do I horizontally shift that function right there?
x minus h, so inside the.
That's great. See the advantage we have because we wrote this as y equals, I don't know where to put stuff on that. We're gonna figure out where it goes in that form in just a minute. Well, let's do a stretch compress. What are we gonna do?
Put a in front of the square root.
Now, we gotta be a little bit careful here.
Yeah.
Because every once in a while, somebody wants to write a plus or minus the square root of x. Anyone see the problem? That's a multiplication, but it sure doesn't look like a multiplication. It sure looks like I'm adding or subtracting something. So I gotta be really, really careful here. The easy way to do it
That's what happened.
is to just go plus or minus a square root of x. And since a can be positive or negative, it doesn't actually change anything. I've still got a plus or a minus. If I put in a negative, that becomes, whatever. It still becomes a plus or a minus. All right, let's put them all together. Y equals plus or minus a square root x minus h plus k. I'm going to make a note here because something weird is about to happen. As this is a vertical stretch. Agreed? A is greater than 1. It gets taller. A is between 0 and 1. It gets flatter. So I would have this versus this. And then in the middle is my y equals square root of x. Okay. Here's what I want to do next. This is fine. I can put this in my calculator. I put 2 pieces in my calculator. We're just going to assume that Desmo is not a thing for now because it messes up the exploration because it just tells us everything. Makes it less fun. I want this to be in x equals form. What's my first step?
You could subtract k.
Let's do it. Next.
Divide by.
I'm going to change that up a little bit. I'm going to multiply by 1 over a, which we know is the same thing, agreed? The reason I want to multiply by 1 over a is I sort of want to keep certain things separate. I want to get things mixed together. What's next?
Square both sides.
Square both sides. What happens to the plus or minus when I square both sides?
Go away.
Why?
Because squaring a negative or positive ends up in a positive.
Absolutely. So when I square both sides, what I get is 1 over a squared, y minus k squared, and x minus h. Plus or minus goes away. Now what?
Add h.
Add h to both sides. X equals 1 over a squared and y minus k squared plus h. What's K? Vertical shift. What's H? Horizontal shift. What is that thing right there? Which direction?
Up and down.
My guess is horizontal.
So here's the problem. This is why I said we're gonna have to be a little bit careful here and why I made a big deal out of this. If I make A big, what happens to this? A vertical stretch over here becomes a compression over here, or a horizontal stretch. Say again?
It makes sense because it's on that one crossword.
Yeah. This is why we had to be a little bit careful. I thought about changing this letter and then making that A, but I don't like that because it's not really A. This is a vertical stretch. This is a horizontal stretch. And I'm going to have you play around with this in just a second. Right now, I'm going to do something. I'm going to call this C. I want you to type that into Desmos. You can't type it into your graphing calculator because your graphing calculator requires y equals, and this is x equals. And when it says, do you want to make sliders for C, K, and H, what are you going to do?
Oh.
What happens when you make C bigger? You drag your slider and drag C to the right to make it bigger. Yeah, it stretches this way. So this is actually what we call a horizontal stretch. We're not going to spend a whole lot of time talking about horizontal versus vertical stretches. We're mostly going to focus on vertical for now. But there's an argument to be made that a vertical stretch and a horizontal compression are the exact same thing. You stretch it this way or smash it that way, it looks exactly the same. And conversely, that a vertical compression and a horizontal stretch are the exact same thing. But they tend to look different in the equations. And this is where we've got to be a little bit careful. Guys, also notice that if I move the h to the other side, and if I go back up to here, I get that x minus h equals c times y minus k squared. And notice again, if I put the transformation with its letter, then it's always minus. The reason it's the other way around normally is because we write everything as y equals so that we can stick it into our calculator. I can put this into my calculator. It requires two different equations, but I can put it in my calculator. I can't put this in my calculator. I definitely can't put this into my calculator because it doesn't let me do that. Desmos lets you do that. Desmos lets you type in anything. So it's a cool program.
Why don't graphing calculators let you type in anything?
Graphing calculators are designed, well, okay, first of all, let's rephrase your question. Why don't the graphing calculators that we use here at the school let us type in
Okay.
anything?
Okay, yeah.
I have a Hewlett Packard HP 49G Plus at home. Lets me type in anything. And I've had that thing for 20 years, so it's not new technology. The Texas Instruments platform that we use, the 8384 platform, is, or was, I want to say specifically targeted towards high school, early college math. And they said, I don't know what, for sure that this is what they said, but this is how they marketed it. They have been marketing 83s and 84s to high school level math / early college. And you don't want to make it too complicated. You want to make things really straightforward and simple. Well, what do we study in early college / high school math? We study functions. We don't do a whole lot of non-functions except to talk about, well, what does this look like as a function? Oh, look, we need 2 parts to make the function. You start to get into the other stuff, and I think, and again, I'm speculating because I wasn't around and I don't work for TI. I'm speculating that if you start to allow this in your calculator, it confuses people who are just learning about this. They don't know what to do. When you can type in any letters you want, well, then what's the difference and how do I know when to type in which? That would be my guess.
Yeah.
The 8384 very, very definitely is a high school to advanced high school sort of calculator.
I just think if I would have learned it that way, it would have made a lot more sense to me. I would have caught on to it a lot quicker.
You mean
Instead of
with
having to kinda- Cause I came from algebra and I kind of had to relearn it here a little bit.
yeah,
And it's just a whole lot easier if it was
you're
just like
talking
that.
about like having the y minus k or the x minus
Yeah,
h
the
instead
both the
of.
minuses are there and
Yeah.
there's no plus or minus or anything.
No, I don't disagree with you. It's one of the reasons I make a big deal out of the way we learn it is, if you add a number, then it goes up. And then when we talked about this, we talked very specifically about where is the x-intercept. And so it was, it made sense that that was opposite. I don't disagree with you though. Yeah, so yeah. The only bad thing about the HP 49G Plus, which was a very expensive, very powerful calculator, the buttons suck. They do, they're horrible. I spent a ton of money on this calculator because it's better. And when you're trying to type stuff in, as soon as, I hadn't had it for 2 years and the buttons started being sticky and not working properly, and it was very, very frustrating. The other fun thing about it, have you guys ever heard of RPN notation? Reverse Polish notation. Here's how your calculator works. You type in 2, you type in times, you type in 3, you type in equals, and the calculator spits out a 6. This is normal notation. RPN, reverse Polish notation, you type in 2, enter, 3 times, and it spits out a 6.
That's a lot of typing.
Well, it's 4 keys instead of 4 keys, so no,
Well,
not
I know, but
really.
like if you're getting into bigger numbers, then you're like,
Yeah, but it's still 1, 2, 3, 4 keystrokes. 1, 2, 3, 4 keystrokes, and you get.
I know, but if you're doing like 49 times 49.
You'd still have to type 49 times 49
49
equals.
times.
No.
What?
No, so, I see what you're saying. So you're under your example, your calculator, you would type 1, 2, 3, 4, 5, 6 keys, right?
Yeah.
I would type 4, 9, enter 4, 9 times. Still 6 keystrokes.
Oh, okay.
Now.
I thought you meant like they typed it like all the way down.
Yeah, no.
That's just addition.
So here's the advantage to RPN notation. In RPN notation, I would type 4 enter, 6 plus, 3 times, 5 plus, squared 2 times.
That would just confuse me after a while.
Well, actually, it confuses you at first, and then it gets really easy.
Yeah.
Because you just start at the inside of your parentheses and work your way out. You guys have to type all the parentheses, and guess what happens if you get to the end and you haven't typed the right number of parentheses? You either get an error or you get the wrong number. It's very, very difficult to get the wrong number using RPN because you just start at the middle and start working your way outwards. You don't have to worry about having the right numbers of parentheses. You just work your way out. It takes a little bit of getting used to.
Yeah.
Once I got used to this, I could do huge calculations, which by the way is one of the things you do in engineering. I could do huge calculations without ever making a mistake. Because the longer the equation gets, the harder it is for a TI-84. Because what happens when you're typing in a really long equation? It starts to scroll off the screen.
Mm-hmm.
Well, I'm never typing in a really long equation because I'm just doing the next operation and then the next operation and then the next operation and then the next operation. And I never have to worry about, oh man, half my things rolled off the screen and I can't remember how many parentheses there are and I can't remember whether this is supposed to go with that part or that. It's just like bang, 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 bang. You're just working your way down. At the end of the day, it's really straightforward and simple and you get the right answer. I loved it. I absolutely loved it. But I wasn't having to teach anybody to do anything either. I was just doing stuff. Now it was awesome. So there you go, reverse Polish notation. Things that the other math teachers will never mention. My very first college calculator was an HP CB41. Wasn't graphing. Just let you calculate stuff. Any questions about the sleeping parabola? Let's do this. We've got another non-function to explore. We've got all day tomorrow. Because my A group, I only had one day and I had to hammer through everything in one day. So I didn't tell them about RPM. We didn't have time. What?
I forgot there was no school.
I didn't. I forgot there was no school Friday. Let me rephrase that. I never knew there was no school Friday.
Yeah, I'm starting to wonder.
I showed up.
Like, why are you doing homework on Friday at like
That's why.
on
That's
time? And I'm like,
That's why I assigned everybody homework on Friday, because I thought we had school. And I showed up Friday morning, 7:15. It's always weird, I'm the first person here. I'm never the first person here. And I came inside and Roberto's in with a big buffer and he says, hey, what are you doing here? And I said, well, I work here. And he says, on a holiday? What? Okay. So I came in and I sat at my desk and I did some work and then I went over to the gym and I worked out and then I left and I had a 3.5 day weekend. It was awesome.
what was the Friday holiday?
Midwinter break.
Oh, okay.
Yeah, they just, so with the way they do the calendars, they sit down and they block off all the things that have to be holidays. You know, we are going to have President's Day off and we're going to have Martin Luther King. We're going to have Thanksgiving and they block those all off. And then they have X number of days of school.
Right.
And so what they do is then they look at it and they say, okay, well, we're going to have spring break and we're going to have Christmas. So when does Christmas start and they block off Christmas and they block off spring break. And then what they usually do, and this is something they started doing years ago, is they said, well, look, there's a 3-day weekend in January. There's spring break at the beginning of April. What do we got in between Martin Luther King and spring break? Well, not much of anything. You know what? Why don't we make a 4-day weekend right smack in the middle? We already got a 3-day weekend, so we'll put an extra day on that weekend.
So there isn't a real reason, they just did it to competition.
Just to give us, I mean, we're gonna be at school the same number of days no matter what.
Yeah.
We're gonna be at school 180 days a year. So it doesn't matter whether we just did 4 days a week all year,
Right.
or we could just do 180 straight days and then have 6 months off, 7 days a week, 4 weeks a month for 180 days with no breaks. And then take 6 months off and do nothing. Okay, so what I'm gonna do is tomorrow, we will look at the other non-function. What do you need out of this? What should you have highlighted? You should have this. And you should have that graph. And that's what you need to know about this one. Oh, and no, you don't really need this. But if you wanted to put that into your calculator, then you sort of need to know this. And I'm going to give you the rest of the period. You guys can work on homework or whatever. We got 12 minutes. If you haven't done your homework, get some homework done. I'm pretty sure you haven't done at least one of the homeworks because I just put it up right before this class. So I had the Friday assignment. So last week I had the Friday assignment up. And I had somebody, this is Algebra 2, and I had somebody emailing me on like Tuesday. Mr. Emery, I can't watch the video from the Friday assignment. It doesn't exist. Like, oh, because I had it set to not open until Friday, because I figured people would be doing it on Friday. But I just went back and changed it and said, oh yeah, there you go. All right, but you can either do homework or do nothing. But you can have this next 10 minutes to get something done. Cool.
What did they do tomorrow's classwork?
What's that?
I said we're gonna do tomorrow's classwork.
No, don't do tomorrow's classwork, because then it won't be fun. Okay, I gotta end this too.